everyone. I just want to say a few more things about molecules and what happens when they absorb light. And I don't think I ever mentioned that when a molecule absorbs UV-Vis radiation, it's only the outer electrons that are excited. And sometimes during a transition, the molecule changes geometry. And the example that Harris gives is for formaldehyde. Here is the Lewis dot structure for formaldehyde, where you have that trigonal planar geometry around that carbon atom. If you hit it with UV radiation, this carbon-oxygen bond lengthens, and this hydrogen-carbon-hydrogen bond gets a little bit more narrow. And if I had to ask you, which electron do you think would get excited when hit with UV-Vis radiation? If you're thinking that it's probably one of these non-bonding electrons, you're right. The other thing that can happen when a molecule absorbs light is that the electron can change spin. Now, spin, you may remember, is a quantum number with the symbol m sub s, and the allowable values for m sub s were +1/2 or -1/2. And you often represented that as an arrow, spin up, spin down. These arrows represent electrons, and they are in an orbital. So what we're going to do is draw some energy level diagrams, and we're going to be promoting electrons in them, but we're going to be including this idea of spin. So I'm going to draw my ground electronic state, and I'm going to put a few vibrational energy levels in there since we're talking about molecules. And when we introduce the idea of spin, we changed the nomenclature slightly. This is no longer the ground electronic state. This is the ground singlet state. And I'm going to label it as S sub naught for ground singlet state. It's just our ground electronic state. And let me put a pair of electrons there. Here they are. Notice one is spin up, one is spin down. We say that those spins are paired. So now we're going to hit our molecule with UV radiation. One of these electrons is going to get excited. Let me redraw my ground singlet state. And here is my excited singlet state. Let me label that. This is the excited singlet state, and we'll label that S sub 1. Now, when UV radiation hits our molecule, one of these electrons is going to get promoted. Maybe I'll promote this one. So here we go. One electron got promoted to that excited singlet state, but notice that the spins are still paired. One is up, one is down. But under certain conditions, for certain molecules, in certain solvents, at certain temperatures, and at certain pHs, another possibility exists. Let me redraw my ground singlet state, S sub naught. Instead of going to this excited singlet state, again, under certain conditions, we can go to an excited triplet state. So this is the excited triplet state, and it is lower in energy than this excited singlet. Let me label it as T1. That's what we usually call it. Now, How does this transition look? I'm going to promote this electron to the excited triplet state, but it's going to change spin. Do you see how that happened? We no longer have spin up and spin down. We have spin up and spin up. The spins are unpaired, or they are no longer paired. Now, these excited electronic states that we've labeled singlet and triplet, they're very short-lived. An excited electronic state barely lasts 10 nanoseconds. So when this electron relaxes from the excited singlet back to the ground state to release a photon, that is called fluorescence. And when this electron relaxes from the excited triplet state to release a photon, that's phosphorescence. So fluorescence and phosphorescence are both types of luminescence, which is the final topic in this chapter. And I think I'd rather tell you about luminescence in person. So that's it for this video. Thanks for listening.